Good day, everyone. Standing in front of you is a parents of master's tutor, and today in this particular video, we are going to be talking about set theory. Set theory. So before we dive in fully in all the subtopics under set theory, we are going to start with the introduction to set theory. If we are talking about the introduction to set theory, then we are going to start with the definition of sets. What is a set? In a simple manner, set simply means the collection of objects. So this simply means that set simply means the collection of objects. So the object present in a particular set can also be referred to as elements. The object can also be referred to as elements or members and it can be denoted by this sign. So since we've already known that set is a collection of objects, the object that is present in a particular set can also be referred to as the element or members, and it can be represented by this sign. Are you there with me? So guys, you have to know that the objects of a particular set are always enlisted in a curly bracket. The object of a particular set are always enlisted in a curly bracket. You can also refer it as curly brackets, or you call it braces. So this simply means that the type of brackets that we use in listing the members of a particular set is a what? Curly bracket. Then another thing we have to note is that for a particular set, are you there? We have to know the number of elements present in that particular set. So the number of elements that is present in a particular set is what we refer to as the cardinality. Cardinality or order of sets. Let us represent a particular set as this is set A equals to A, B, C, D. So guys, this is set A. So whenever we are using alphabet to represent sets, we are going to be using capital letter. But whenever we are using alphabet to represent the members of a particular set, we are going to be using small letters. So this is a set. This is set A. These are the members of this set A. They are listed inside a curly bracket. But if I want to know the number of members that are here, then I will say that n of A is equals to 4. Because we have 4 members here, 1, 2, 3, 4. This n simply means cardinality. And cardinality of a set simply means the number of members present in a particular set. So n of A is equals to 4. So the next thing we have to know about the introduction is that we can say that, you know, the first members of this set A is this small a. We can say that A is an element of A. The next member is B. We can say that B is an element of A. C is an element of A. D is an element of A. But you will say that there is no F here. So we are going to say that F is not an element of A. G is not an element of A. So what we mean is that this sign simply means members. It simply means member or belong. So we can say that another term for object is element or member, or we use the term belong. So we can say that A belongs to this set A, B belongs to this set A, C belongs to this set A. Present here, but F is not here. So we are going to say that F does not belong to A. G is not here. We are going to say that G does not belong to A. So this is the what? Introduction to set. Then let's move on to types of sets. Let's talk about types of sets. We have the finite and infinite sets. We have the empty and singleton sets. We have the equal and equivalent set. Let's start with the first one, finite and infinite. Finite and infinite. Guys, you have to understand something, that infinite is like the opposite of finite. Infinite is coming from the term infinity. We all know what infinity means when something has no ending. So this simply means that a finite set is a set that has countable elements. It has countable elements. But infinite set is a set that has uncountable elements. Uncountable elements. So finite set has countable elements, infinite set has uncountable elements. So if we want to talk about an example, let's say we have let's say set A is equals to days of the week, and set B is equals to stars in the sky. So guys, you are going to agree with me that we have 7 days in a week. So that simply means that the members of set A are countable because we only have 7 days in a week. So this simply means that set A is finite set. Set A is finite set. But if you look at the stars in the sky are uncountable. So we are going to say that set B is infinite set. Infinite set. So that is the definition of finite set and infinite set. Then let's talk about the empty and singleton set. So guys, if you're talking about the empty and singleton sets, guys, you also have to understand something, that the empty is coming from when there is nothing, while singleton is coming from the term single. So this simply means that empty set has no elements. No elements. Empty set will have no element, while singlet set will have one element. One element. So a set that has no element in it is referred to as what? Empty set. But a set that has only one element in it is referred to as what? Singleton set. Now, this empty set is always represented as this or this. So we always represent empty set as empty curly bracket without putting anything inside the curly bracket, or we use this phi. So this is a representation for an empty set. But for singleton set, we can represent singleton set as this, a set that has only one element, or this. So you can say that you must not confuse singleton with empty. If you are talking about singleton set, it is either you use curly bracket without putting anything inside it, or you use this sign without putting this sign inside the curly bracket. But if you're talking about singleton set, that is when it has only one element, that's 0 or 5. Then let's talk about some example of empty and singleton set. Let's say we have set C is equals to female presidents in Nigeria. Set D is equals to VC of Lautech. So we are going to see that since the independence of Nigeria, there hasn't been any female president. Then this simply means that female president in Nigeria, there is none. So set C is an empty set. Empty set. And if you're talking about the VC of Lautech, this simply means Lautech is an institution, is a university. And VC simply means the vice chancellor, that is the head of the institution. So we always have one VC at a time. So this simply means that we are talking about the vice chancellor of Lautech, VC of Lautech. So if we always have one at a time, then set D is a singleton set. So therefore, guys, once we've understood finite and infinite, empty and singleton, then let's move on to equal and equivalent sets. Equal and equivalent sets are two different things that you must not be confusing together. If we are talking about equal sets, we are going to be talking about same members. But if you are talking about equivalent sets, we are going to be talking about same cardinality. So this simply means that when two sets as same members, irrespective of how the members are being arranged, once they have same members, we are going to say that the sets are equal. But once two sets have same number of elements, Are you there? We are going to say they are what? Equivalent. So same members is for equal set, same cardinality is for equivalent set. Then let's talk about the examples of equal set and equivalent set. Now, let's say set A equals A, B, C, D. Set B equals B, A, C, D. So guys, if you look at set B and set A, if you look at set A, we have A, B, C, D. If you look at set B, we have B, A, C, D. So you are going to agree with me that set A and set B, they have the same members, irrespective of the arrangement. That is, all the members in set A are also present in set B. So we are going to say that, number one, A and B, set A and B are equal sets. And also, if you check this again, you will say that in set A, we have 4 members. In set B, we also have 4 members. So this simply means that set A and set B, they have the same. Set A is 4. You know the number of elements present in a particular set. That is what we mean by the cardinality. The cardinality of set is also 4. So this simply shows that set A and set B, they have the same cardinality. So once they have the same cardinality, this simply means they are what? They are also equivalent. Set A and B are equivalent sets. So this simply means that this set A and set B, they are both equal and they are both equivalent. Now let's look at another example. Set C is equals to A, B, C, D, and set D is equals to 1, 2, 3, 4. So guys, if you check, 1, 4, 3, 4. If you check this set C and set D together, we are going to say that, number one, we are going to say that all the members in set C are not the same as the members in set D. So this simply means that they don't have same members. They don't have same members. So since they do not have same members, this simply means that set A and B are not equal. Since they don't have same members, this simply means they are not equal sets. But if I look at set C, I'll say that the cardinality of set C is 4. If I also look at set D, that simply means that the cardinality of set D is also 4. Then I'm going to say that and B are equivalent sets. So guys, you are going to see that this set C and set, C and D. You know we are dealing with set C and D. So sorry guys. So set C and D are not equal sets because they do not have the same members. Before we can say that two sets are equal, they must have the same members. But set C and set D, they are equivalent sets because they have the same cardinality. The cardinality of set C is 4. The cardinality of set D is also 4. So this simply means set C and set D, they have what? Same cardinality. So they are what? Equivalent. So therefore, guys, to end this particular video, you have to note that all equal sets are always equivalent. All equal sets must be equivalent. But all equivalent sets are not always necessarily equal. All equivalent sets are not always necessarily equal. Thank you for watching. In our next particular video, we are going to be talking about the set listing and terminologies of sets.